hot, dense state that nearly 14 billion years ago expansion started. Wait, the earth began to cool, the autotrophs began to drool, Neanderthals developed tools, we built a wall. We built the pyramids. Math, science, history, unraveling the mystery that all started with a Big Bang.
The Big Bang Theory is the most prevalently used theory about the universe because it best explains everything that we see about the universe. The person who proposed the Big Bang Theory was Georges Lemaître. He was born in Belgium in 1894. Growing up, he was interested in science and the theology behind it. However, he initially studied civil engineering at the Catholic University of Louvain and was later ordained as an abbé in the Catholic Church. Bridging the gap between science and religion despite his relationship to the Church, he went on to study physics at the University of Cambridge as well as at Harvard University and went on to receive his PhD from the Massachusetts Institute of Technology. Studying Albert Einstein's laws of gravitation and using the theory of entropy, which says matter favors a more disordered state, Lemaître developed his Big Bang Theory. In 1927, he published an article which proposed the idea of an expanding universe, contrary to the belief that the universe has remained static in size. In 1929, Lemaître confirmed that the universe is expanding with the help of Edwin Hubble and his observations of what is known today as red light shift, where electromagnetism distorts light coming from distant galaxies. His argument, based on the thermodynamics of quantum theory and mathematically derived equations, was that if the universe is indeed moving outward, then at some point in time in the past, the universe must have come from an initial starting point where all matter was compacted and compressed. This initial starting point was called the cosmic egg. After exploding, the radioactive decay produced from the atom created all known natural elements whose creation played an important role in the production of the planets and continually plays an important role in the universe today as we know it.
Specifically, the three evidences that support the Big Bang Theory are background radiation, redshift, and expansion. The redshift concept stems from the idea of traveling light. The closer something is to Earth, the higher the frequency of that wavelength is. Blue light has the highest frequency, while red has the lowest. In 1924, Edwin Hubble discovered that stars from other galaxies are becoming more and more red, which meant that they are moving further away from Earth. Furthermore, he observed the relationship of a variable star's energy output and the amount of time needed for it to pulse illumination. In 1912, American astronomer Vestal Melvin Slipher was able to calculate the speed and direction of a spiral nebulae by measuring changes in the wavelengths illuminating from them. From this and other variables, Edwin Hubble was able to calculate how far away these stars were. If these galaxies are moving rapidly away from us and are indeed far away, this suggests that the universe must have been located in a single point billions of years ago. The third evidence that supports the Big Bang Theory is the cosmic microwave. This is a background radiation that lingered from the early life of the universe. This was discovered by American physicist and radio astronomer Arno Penzias and Robert Wilson in the 1960s. They were experimenting with the radio telescope when they discovered a background radio emission coming from seemingly every way in the sky with temperatures measuring just above absolute zero. The radiation that was discovered is proposed to come from the cooling of the once hot universe. As the universe kept expanding, so did the cooling of everything in it, which created other molecule and life forms that we see today. More recently, in 2014, a Harvard team discovered primordial B-mode polarization, or twist of light, which refers to the swirling effect that enormous gravitational waves had on photons that escaped from the Big Bang. In Einstein's theory of general relativity, he hypothesized that these waves exist as ripples in the fabric of space-time. If these waves do in fact exist, that would mean the rapid expansion of the universe after the Big Bang actually happened.
From early stages, the Big Bang Theory model received both supportive and resentful feedback. In 1905, Einstein deemed that the world ran under principles of physics he coined as a theory of general relativity, where the universe would remain static in size. However, Many scientists of the era refuted his position by stating that the universe is ever expanding. Le Metrier's Big Bang Theory solidified the concept of an ever-expanding universe by stating that everything in the universe was created from a single point in time and space. This concept was subjected to many opposing views in the scientific world, while it was embraced in the Catholic community. Pope Pius XII represented the views of the Catholic Church, stating that the idea of the universe stemming from a single point in space followed the current beliefs of creationism and proved the existence of a God. The statements made by the Pope made it easier to accept on a religious level for individuals because it partnered well with the Bible. As stated in Genesis chapter 1, the story of creation is explained as followed. In the beginning, when God created the heavens and the earth without form or shape, with darkness over the abyss, and a mighty wind sweeping over the waters. Then God said, "Let there be light," and there was light. The acceptance of this model in the scientific community was divided among two distinct groups: those who believed that the universe had a beginning, and those who did not. One of the biggest adversaries of the Big Bang model was mid-20th century English astronomer Fred Hoyle. Hoyle disapproved of the idea that the universe had a specific point of beginning, and instead argued this model could only be legitimized in a religious context. Instead, he argued for Sir James Hopwood Jeans' slow steady model, which explained that expansion would result in a slow and steady growth of the universe due to the continuous addition of minute amounts of matter throughout time. The steady-state theory also mentions that the universe is always expanding but maintains a constant average density. This means matter used to form stars created at the same rate as older stars becomes unobservable. Jeans' theory was soon ruled out in the 60s when microwave background radiation began to be seen as proof of a Big Bang.
In the late 70s, Andrei Linde proposed the eternal inflation theory. He built this theory upon Alan Guth's inflation theory, which stated that during inflation, the particles once near each other were then separated into different and far-off locations, aside from the immense vacuum energy that drove the expansion. After the inflation stopped, the vacuum energy decayed and cooled into particles that later formed the cosmos we know today. One of the implications of the Big Bang Theory is that the universe will one day end, or at least any life in the universe will come to an end. If the universe is either open or flat, meaning that it expands forever, it will survive for an infinite period of time. But eventually, all the materials in all the generations of stars will be exhausted and the universe will grow cold and dark. In a closed universe, in which the expansion eventually stops and a contraction follows, the end is far from cold and dark as the Big Crunch approaches. The universe grows hotter and brighter until it implodes into a singularity and gets crushed out of existence. But is that what would really happen? Einstein, along with other scientists, briefly proposed the oscillating universe theory, which they speculated that the Big Crunch would not signal the end. Perhaps another Big Bang would follow the Big Crunch, giving rise to a new universe of possibilities. And that was how we proposed the universe was created.